Alright. What is your name?
Okay.
Can tell Tyler. And what math class is this, Chantal? 101. And you said it was with Johnston?
Yep.
Alright. What are we working on today, Chantal?
We have a test coming up
Okay.
on Thursday. And she gives us like kind of a everything that's gonna be on it. And I just wanted to like review over some stuff.
Okay.
Because she
That's okay. We can take a look at some things. Is there anything in particular that you're stuck on?
like some of these you have to write like if it's independent, dependent, and then like one infinity or none.
Okay.
And she didn't ever describe like what any of that meant, so I'm not exactly sure.
Okay. Do you want to maybe find the section in your book real quick that has those, and we'll go over them?
I think it's system. I think it's system.
Yeah, I think we're on the right path. Yeah. All right. Perfect. So, system of equations is basically you have two lines, right?
Yeah.
Or two or more lines. So, and sorry, look here to see what words. Inconsistent, consistent. So let's go over those first. Okay. So here this says consistent system. Okay, so a consistent system is when there's an answer.
Right.
Okay, so my marker doesn't work. Okay. So if we have two lines and they cross, that's a solution, right? When they cross, so that's a solution. So these two lines would be an example of a consistent system.
There's a point intersection.
Yeah. So there has to at least just be one point. So we could have two lines that are exactly on top of each other, and there's like infinitely many solutions, right? Because they hit each other infinitely many times. Also consistent. So just remember, consistent means there's an answer.
When there's parallel, it'd be inconsistent because they don't.
Yeah, they never cross, right? That's really good. Yeah.
That's probably.
And most of the lines that you work with are gonna go on forever, right? And so technically, parallel lines are the only time that we don't have them, right? Because if they go on forever, eventually they're gonna cross somewhere, but not parallel lines. Right. And that's what she has one infinite or none, one solution. They cross one time.
Infinite is just like
they're the same line. So you could be given two equations like 2x plus 4 equals 6 and 4x plus 8 equals 12. These are the same line. They're just, if you divide this one by 2, you get that one. So that's two lines that lay on top of each other. So you have infinitely many solutions. Does that make sense?
Yeah.
Okay.
So if they're parallel, is that kind of the same concept? Obviously, because they're the same lines.
Parallel's a little bit different because you have different y-intercepts for a parallel line. So let's draw this and talk about it. We have two parallel lines. Will they ever cross?
No.
So can we have a solution? So this is your case where you have no solution.
Okay.
But like the two equations that I drew you, they're both the same line. They like lay flat on top of each other. So there's infinite solutions. That's the only time you're going to have infinitely many solutions. Okay?
And what does an independent mean?
The end behavior, that is, find the power function of the graph of f for example,
So-
the large values of the absolute value.
Okay, so the two equations I gave you were the same equation, right? But just a different form. So we had y equals 2x plus 3 and y equals 4x plus 6. Same equation, right? You multiply this one times 2, you get this. Divide this one by 2, you get this. This is a dependent system. They're the same equation. Okay?
Well, whatever, like, say, like, on the test, if she has, like, the x and the y, you know, like, they're not.
You want to draw what you're meaning?
Kind of like,
Find the power of yada yada yada.
Sorry.
like, do you know what I mean?
Yeah, so that might be on the test. But not a big deal if it is.
Because, okay, she gives us this stuff, but this stuff is 10 times more simple than what's actually on the test.
Yeah, so these are just definitions, so like learning to apply them to equations is like something different. So if you were to be given something like that, is what's confusing you about the second one? Is that
There's nothing confusing really, because you just have to put it in the same, like,
yeah, just move stuff around.
Yeah, so is that all I'd have to do?
Yeah, you can move it around and then compare equations. That's actually what I would do too. This is just kind of weird to look at if you have the x first. So yeah, no problem.
I don't really about it on that one.
On
I
that
just
one?
didn't
Okay.
know what the definitions technically meant.
Yep. How do you usually study for your tests?
We have like assignments on WebAssign or whatever it is. And you can like watch tutorials and stuff, so I usually watch those over and like read my book kind of.
Yeah, that's really good. If you struggle with definitions, I would recommend using flashcards too, because you can always do those with definitions, and that helps me a lot when I study for tests.
I was here last night actually at that other table, this table, with that other guy, and we forgot to log out because we've never been here before, so
okay.
it didn't count. I don't know if we get anything for it. Okay. This one's just like solving systems by graphing.
Okay.
Like this.
So when we talked earlier about finding a solution, what does that look like on a graph?
Wait, sorry, what'd you say?
That's okay. When we have two lines on a graph, how do you know where the solution is?
Well, you have to like draw the x and y. So, like you figure these out and then you put them on the line.
Yeah, you can graph it, right? So if you graph two lines, like in this, how do you know where the solution is? Where they cross, right? Okay, so are you comfortable with graphing the lines? Yeah, you're good with that? Okay, so basically it's just a matter of when it says to solve it by graphing, graph the two lines and you see where they cross. So for the example you have, I'm going to slide your book over here for just a second. Okay, I'm going to go get a new one.
But there's whatever.
That's much better. Alright, do you want to graph the first line for me?
This one?
Yeah.
Well, I need to figure out like these.
Okay, that's fine.
Well, isn't that just... Oh. Is that right?
So, I noticed here you crossed that off. because you were starting to do 3x and you were plugging 0 in for the wrong one, right? So I think you did that with this one too.
Oh.
So if we plug in 0 for x, you have 3x plus y or minus y equals
Plus
5.
Y.
It is plus y? Okay. If we plug in 0 for x,
Yeah.
3 times 0 is
0.
okay, so then we just have y equals 5.
Yeah.
So that would make that point 5. Okay? So then if you plug in 5,
So it's 5.
so
Wait, am I?
it's okay.
I'm not going to.
No, it's
I
okay.
know
When you do an XY chart, you plug x into the function to see what y equals.
Yeah.
So if
I
we
don't
want to
have much
find
semester.
at what, when x equals 1, if we plug 1 into this equation, so we have 3 times 1 plus y equals 5.
Yeah.
So we have 3 plus y equals 5. So what does y equal?
Well, you have to subtract 3 over. Okay. And then, okay.
That's okay.
Okay. But don't you have to plug the 0 in? Not 1.
Yeah, you can,
But you have to have a checking point.
yeah, you can have any points here you want. It doesn't matter what they are.
Where is this?
Okay, so let's see. You plugged in 1, so you got y equals 2. Perfect. You plugged in 0, so you got y equals 5. Awesome. So if you plug in 2, we have 3 times 2 plus y equals 5. 6 plus y equals 5. So if we subtract 6 from both sides, what do we get?
Wait. Oh, negative 1.
You're okay.
I do not know.
I think you're just trying to think of it like too many steps ahead. Just really focus on plug in x, figure out what your y is. Okay, so let's check this one just to make sure. So when x is 0, so we're using this equation now, right? When x is 0, so how do we get rid of a negative? You're on the right track.
So you divide to the other side.
Yes, this is the same as negative 1y, right? So what do we divide by? Okay, if x is 1, what do we have to do?
Add 1 to the 3.
Okay, or, so we have a positive 1, right?
Yeah.
So how do we get rid of it? Good. So what is y? You got it. You know how to do it. You're just thinking too many steps ahead. Yep.
Yeah, and I know how to graph that. I don't need to graph it because you just put in the point.
Yep, and then just see where they're equal.
Yeah, I get that.
Okay.
And then she said on the test it's going to be like this, x equals, and then y equals, and that's just the point of intersection.
Yeah, so
You know
that's
what I
where your 2 lines like cross, right?
Yep.
Are you confident in finding that? Okay.
Do you know what like matrices are? Okay. So like I get this is also on the test, but like you have to do these type of things, and some of them confuse me because like you have to like multiply and then like add it or something.
Yeah.
And when she did it, she just did it. Like she didn't tell us like what we were doing. She
That's
just
okay.
kind of like handed it to us like we.
So, Chantal, matrices are like actually really fun when you get the hang of them because it's free reign. You don't have to follow any certain steps, you can do whatever you want to get to the answer. Just might take a few more steps, right?
Yeah.
So let's see. The matrix that you're given is 1, -1, 1, 1, 1, 5. Okay.
She gave us the x minus y equals 1 and x squared y equals 5.
So do you understand how we get this matrix from these equations?
The coefficients.
Yep. Yeah, and this is called an augmented matrix. When you have the answer in there, that's an augmented matrix.
Yeah, I get that.
Okay. So are you just confused on?
Like I get the R1 and then R2. But like she did something with like multiplying and adding. I don't even know what she did.
Okay. Yeah. So when you're using matrices, you can switch rows. You can multiply any row times a constant. A constant's like 0, 1, 2, 3, 4, something like that. You can subtract them. You can do any combination of them. Let's just work through this, okay? So we know that we want, in the end, what numbers do we want to have? Okay, so
Like ones or something.
yeah. So you want to have, this is saying x minus y equals 1 and x plus y equals 5. We just want to know what x and y are, right? We don't want to know what their combinations are. So we want to know what x is, and we want to know what y is. So we want this guy to be a 0, and we want this guy to be a 0. We want these to stay 1s. Okay?
That makes sense.
Yeah, because if it's a 0, then you have just x equals 1 and y equals 5. So let's try to do that. So this guy's kind of messing us up, right? How can we get that to a 0?
Subtract. Well, this.
We have a -1 and we want it to be a 0. What do we do?
Add one.
Add 1. So this is a 1,
It
right?
is for sure.
So could we add these two rows? So that's row 1 plus row 2.
I think it counts.
And I always do this. I don't know if you've seen this, but it helps me. This means to replace row 1. So this way, if you mess up, you kind of know where you went wrong. So that would give us, so if we add these two rows together, what do we get?
Add just these two? Or like
So you add
them.
straight down. So 1 plus 1. -1 plus 1. 5 plus 1. And then the second row stays the same. So we got a 0. That's really good, right? That's what we wanted to do. But now we have a 2. Do we want a 2? So how do we make a 2 a 1?
How would you find the least degree though? It
See, that's just kind of like confusing.
what's the real
Okay.
zeros, which I know how to do, and state the least degree.
Tell me your thought process.
So
What's
we
the
want
first
that
thing?
two
That's that
to
your
a 1.
69
You got it.
is the least degree.
Because it has the turning points.
Subtract.
So since this has
So that's what we did the first time, right? We subtract. So that's a really good thought. If we subtract, we have 0 minus 1, which changes that back to a -1. Do we want that to be a -1? No, we just want that guy to be 0. That's what we want him to stay at 0, right? Is there something that we can add to this row or multiply by this row to get that to a
so
1?
you know if you take the number of turning points
You can.
the degree. This is the max number of turning points.
So we've decided we can't add or subtract, right? Because that messes up our 0. So what are other operations you know?
Oh, you can divide it.
You got it.
Oh, is that what you were thinking the whole time?
You got
I
it.
didn't know you could divide on
Yeah.
that.
You can add, subtract, multiply, divide, and switch rows.
Well, you could divide that 2 by 2 to get a 1.
Yep. So divide row 2 by 2. Okay, so that gives us, oops, I'm sorry, row 1. Gives us what?
Sorry, what did you say?
So we're dividing this row by 2, right?
Right, yeah.
Okay, so what do we get on the first row?
0, 3.
Got it.
And then the second stays the same.
Now our top row's really good, right? We got it. So now The next part is what number do we need to change now? One more number we gotta change.
And that one needed to be a 0.
You got it. So we're gonna get this guy to a 0. How do we do it?
Subtract 1.
So this guy's a 1. So could we do row 2 minus row 1? Because that would give us what? This guy stays the same, right?
Yeah, that gives us 1. You want to subtract by 1?
Yeah, so you're
Okay,
taking the
so
second
1,
row.
0,
Perfect.
0.
So 1 minus 0. Because you're
1,
subtracting the rows. So 1 minus 0 is 1. And then 5 minus 3. So what does your x value equal? So this is saying x equals this. So what does x equal?
3.
And what does y equal?
2.
You got it.
That's all you do then? Yeah, she just didn't have to explain that.
Yeah, so just matrices are kind of your own reign. Just make sure you can't just like pull a random number out of anywhere. It has to be a number in here. Or like we divided by 2. You could do that.
Okay.
Yeah, so if you get stuck in your test working with matrices, I would just ask yourself addition, subtraction, multiplication, division, or can you switch rows? Because one of these is going to help you. There's nothing else that you can do. Okay? Don't get frustrated when you work with these because sometimes they can take several steps. So, does that help some?
Yeah, it does. Thank you.
No problem. Do you have any particular story problems? Okay.
And then you have to like use, because there are two equations, so then you have to do like elimination, substitution, that kind of stuff. It's just like setting up the equation, not like always.
Okay. So let's see. Do you have a certain one that we can work on setting up equations?
Well, we did number 44 here last night, and that's the one you had to like help with.
Yeah.
No, actually. Yeah, I think you did. But like the guy helping us didn't even like know how to do it, and I feel like I just got like more confused.
Okay.
After.
So a good process to do when doing story problems is first write what you know. And then second, what is the question asked? Third, how can you get there? And then the next step is just doing the work. Okay, so let's work it out like that. So what do we know from this question? You got 44.
Car loan charges. So the tuition loan is 0.5%.
So we have tuition loan is 0.5%.
And then the car loan is 0.75%.
I don't know where to put me.
And the total monthly is
Yeah, I got it.
Is that a monthly loan?
monthly interest on a total debt.
Okay. So we have done what we need, right? So he pays 95.5 monthly on this much. This is how much he owes total. But this is how much he has to pay monthly based on these. Okay? So second step is how are we going to get there? So it looks like we're going to have a couple equations, right? But what's a good way to split these equations up?
All the other ones I either didn't get a high score. Like I told you, I got 4.
So it looks like this is a monthly loan, and this is a monthly loan. and we have a monthly number. So let's set those up together.
So I didn't go talk to those to get
See, when we did it, we did like 0.5 plus 0.75 equals a 95.50, which was not right. And we kept kind of going back and forth.
Okay.
So
So it's not quite 0.5 and 0.75, just plain, right? Because
Yeah, X and Y.
Yeah. So I'm going to use T and C so we know what one, right? But obviously, your car didn't cost $0.5, right? We don't really know what our car costs. We don't know what tuition costs, right? I mean, we do, but that has nothing to do with the problem. So this is how much we're paying monthly. That's saying 5% of the total cost of your tuition plus 0.75% of your total cost of your car. Okay? So if this is the total cost and this is the total cost, you got it. That's how much they owe total, right? So now you have two equations. Are you good with solving these once you have the two equations? Does that make sense how we got that? So yeah,
So then you just have to solve it.
Mhm.
And you could use elimination or substitution.
You could use either of them, yeah. You could even use your matrices to solve this. I would not recommend using your matrices for these because these are really messy numbers, but yeah.
Oh yeah.
Yeah, I can see that.
Yeah, so just write down the things that you know right off the bat. And if you do that, then you can kind of, like we did, organize things into, hey, maybe this should go here and this should go here, and not really
read this time.
Okay.
So what would this multiply?